Hi students, today we are going to study about critical angle and total internal reflection. This topic is based on the refraction of light from a plane surface. You can look at the diagrammatic representation. I have drawn three diagrams. In the first diagram, I have taken a plane refracting surface XY and N is the normal, okay, passing up to N dash. So N dash is perpendicular to the refracting surface. That is why it is called as the normal. And XY is the line of separation between two media. Okay, below XY, the medium is taken to be denser medium, and above XY, the medium is considered to be a rarer medium. So I can say XY is also the interface. We have studied now what is meant by interface, which separates. It is a line of separation between two different media having two different refractive indices. Okay, now let us take the denser medium is 1 and rarer medium is 2, and the refractive index, okay, this is the absolute refractive index of the first medium is N1 and the absolute refractive index of the second medium is N2. Okay, if there is only one subscript following this refractive index symbol N, then that is called as what? Absolute refractive index. If there are two suffixes, means it is relative refractive index. So N1 is the absolute refractive index of the denser medium 1 and N2 is the absolute refractive index of the rarer medium 2. Now the incident ray is drawn within the denser medium. So I will say that AB, okay, AB is the incident ray. So a ray of light AB is incident on the interface XY. Now, because of the change in the medium, now the light is undergoing refraction at the surface XY. Now, since the light is coming from the denser medium into a rarer medium, the light will deviate away from the normal. You see here, BC is the refracted ray. So, corresponding to the incident ray AB, the refracted ray is BC and it has deviated away from the normal. And the angle made by the incident ray AB with the normal is angle of incidence I, and the angle made by the refracted ray BC with the normal is angle of refraction R. Okay. So in this picture you can very clearly see in this picture that is R is greater than the angle of incidence I. Okay. Now I am going to increase the angle of incidence slowly, degree by degree. Understand that? So from this I am going to increase the angle of incidence. Proportionately the angle of refraction also will increase. Whenever the angle of incidence is increased, proportionately the angle of refraction will also increase. At one stage, what is going to happen? You see here, as this angle of refraction increases, at one stage it will attain the maximum angle of refraction. This is shown in the second picture. So I will take AB is the incident ray and BC is the refracted ray for a particular angle of incidence within the denser medium. Okay, the angle of refraction will be equal to 90 degree, which is the maximum possible angle of refraction. Okay, so comparing to the first picture, what I have done is I have increased the angle of incidence such that the angle of refraction has reached its maximum value 90 degree. In this position, you can see that the refracted ray BC is lying on the interface XY. That means it is grazing the surface of separation between the two media. It is grazing the surface. Understand that? So I can say that for a particular angle of incidence, okay, the angle of refraction is 90 degree and the refracted ray just grazes the surface of separation between the two media. This particular angle of incidence is called as critical angle. Critical angle. So I am going to write this as I critical. Okay, critical angle. IC is called as critical angle. So this is the title. We have written critical angle. So how to define this critical angle? Critical angle is defined as the angle of incidence. So this is the angle of incidence. Okay, this is the angle of incidence. First of all, okay, where inside which medium? Inside the denser medium. It is the angle of incidence inside the denser medium. Okay, what is special at this angle? What is special at this angle? At which R is equal to 90 degree. Angle of refraction is equal to 90 degree. So in the examination, if you are asked to define critical angle, means you have to write this statement. So critical angle is defined as the angle of incidence inside the denser medium at which the angle of refraction is equal to 90 degree. A short definition you write. Full mark will be given. Understand? Okay children, now if we increase the angle of incidence further, what is going to happen? Let us see. Before that, once again, let us recapitulate the first picture. I have shown the diagrammatic representation here. A, B is the incident ray and B, C is the refracted ray. And let us take another dotted ray. You see here, BD. For every incident ray, partially light will be reflected also. We are studying refraction in this topic, okay. It does not mean that reflection does not happen. Along with refraction, a certain portion of the light will be reflected also. Maybe the percentage of light reflected will be less. For example, if 20% of the light is reflected, 80% of the light will be refracted. But we have to show that the reflected light by the dotted line. Okay. In the second picture also, there will be a reflected ray. That is a BD. But what is the angle of refraction? Maximum angle of refraction is 90 degree. So here also 80% is refracted, 20% of the light will be what? Reflected. Okay, that will happen simultaneously. But in the third picture, I am going to increase the angle of incidence beyond the critical angle, greater than the critical angle. Understand? Here second picture, I have measured the angle of incidence equal to critical angle. Understand? Now what is going to happen if I will increase the angle of incidence greater than the critical angle? That is shown in the third picture. So A, B is the incident ray and here the angle of incidence is greater than the critical angle. And now refraction will not take place. So I will write here no refraction. Understand? No refraction will take place and 100% of the light will be totally reflected. Understand? So this BC is now not the reflected ray. Here 100% light is reflected. So 100% reflection only will take place. No refraction will take place. At least in the first picture and the second picture, 80% of the light underwent refraction, only 20% or less will be reflected. But in the third picture, 100% of the light will be reflected only. That means no refraction will take place. This is why this phenomenon is called as total internal reflection. The word total means what? 100% of the light will be reflected. The word internal means what? Within the first medium itself, within the denser medium itself. So there is meaning in the statement total internal reflection. Totally 100% of the light will undergo reflection within the first medium itself. No refraction will occur. So this is only called as total internal reflection. Okay, now from this we can get an expression relating the critical angle and the refractive index of the denser medium. Understand that? So we are going to derive an expression relating the critical angle IC and the refractive index of the denser medium, N1. Understand? For example, if first medium, okay, if first medium that is denser medium is water, for example, okay, water, then N1 is equal to N. Okay, 1.33 is the value for water. And second medium, if second medium, that is the rarer medium, outside. Okay, second medium means what? Outside medium. That is the rarer medium. And if it is taken as air, then N2 is equal to 1. Understand that? Okay. Now from Snell's law of refraction, sine of the angle of incidence divided by sine of the angle of refraction is equal to refractive index of the second medium divided by refractive index of the first medium. This is the starting point of the derivation. Okay, now I am going to refer to the second picture. I am going to apply it in the Snell's law. In the second picture, what is the angle of incidence is IC, is it not? And the angle of refraction is how much? 90 degree. Am I right? So I will write sine of the angle of incidence is equal to the critical angle IC. Understand? And divided by sine of the angle of refraction corresponding to the critical angle is 90 degree. I have substituted. And this is equal to, instead of N2, what I can write now? Instead of N2 is 1. Instead of N1 is N. So see here, instead of N2, I am substituting 1. And divided by, this is N. Very simple. What is the value of sine of 90 degree? Sine 90 is equal to 1. Numerical value is equal to 1. Therefore, sine IC, okay, sine of I critical is equal to 1 by N, or what is critical angle IC is now equal to sine inverse sine function, okay, sine inverse of 1 by N. That's all over. The derivation is over. If it is asked as a 3-mark question or 5-mark question, up to this you have to write. But in general, it will be asked as a 3-mark question only. What will be the question? Define critical angle and obtain the relationship between the critical angle and the refractive index of the denser medium will be the question. Suppose if it is asked as a 5-mark question, in addition to this, what they may ask, mention the 2 conditions required for total internal reflection to take place. So that also as a tag. Okay. So what are the 2 conditions required? Okay, required for total internal reflection. So condition number 1, light should travel from which medium into which medium? Light should travel from the denser medium. Understand? So we will write light must travel. Okay, travel from denser medium. Okay, from denser medium to rarer medium. Okay, so here denser medium we have taken as water and rarer medium we have taken as air, for example. Okay, what is the second condition required? The angle of incidence within the denser medium should be greater than the critical angle. So we have to mention that within the denser medium, the angle of incidence I should be greater than the critical angle IC. Understand that? So this is a very, very important topic and also very easy and simple. So you start always your preparation from easy topics to difficult topics. Then only you will gain confidence. I hope you must have understood well. Fine.